Well, hello there, Algebra 1. Today we're going to be learning about arithmetic sequences as linear functions. So you want to take out your notebooks and begin taking notes. The first thing you're going to take notes on is this vocabulary. A sequence is a set of numbers, and I'm going to be showing you examples of sequences. A linear means a line. So anytime you see linear, you see the word line inside linear. That always means line. So in algebra, we're going to be dealing with lines. The terms of the sequence are the numbers in a sequence. I'm going to jump over here and just show you. This is an arithmetic sequence, and these are the terms in the sequence. Okay? An arithmetic sequence is when the difference between the terms is constant. And again, I will show you that. And the common difference, which we call D, is the difference between the terms. So get all that down into your notes. Over here, this is an arithmetic sequence. It goes from 3 to 5 to 7 to 9, and ... just tells you that it goes on. So what is the difference between 3 and 5? Well, I would add 2 to 5 to get 2 to 3 to get 5. To get 7, I would add 2. To get 9, I would add 2. So this is an arithmetic sequence where D is equal to positive 2. In this case, I go from 10 to 7 to 4 to 1 to negative 2. Well, this is my first term. If I subtract 3, I get 7. If I subtract 3, I get 4. If I subtract 3, I get 1. If I subtract 3, I get negative 2. And you keep going on. So the D in this case is negative 3. So here's a problem that I want you guys to try. I'm going to show you the first example, and then you can try the second example and determine whether it's an arithmetic sequence. So the problem is determine whether each sequence is an arithmetic sequence. So you basically have to figure out if D is always the same. So you have to figure out, okay, what do I do to negative 4 to get it negative 2? Well, you would add 2 to that. Okay, what do I do to negative 2 to get 0? Well, again, add 2. What do I do to 0 to get 2? Add 2. So my question to you is this an arithmetic sequence? Yes, it is, because D is always 2, and therefore it's an arithmetic sequence. Let's see what I have to do over here. This one's a lot harder than that one because we're dealing with fractions. So how do I get from 1/2 to 5/8? Well, I'd have to do some subtraction to figure it out. 5/8 minus 1/2. You'd have to find your common denominator. 5 minus 4 is 1. So I am adding 1/8 to this fraction to get that one. So far my D is 1/8. Now again, I would have to subtract 5/8 from 3/4. So I'm going to do 3/4 minus 5/8. I have to find a common denominator. 4 times 2 is 8, so 3 times 2 is 6. So I'm doing 6/8 minus 5/8 is also 1/8. So I know so far this looks like an arithmetic sequence. Let's do the next one, 15/16. 15/16 minus 3/4. Okay, how do I get that? Well, I keep my 16 as my common denominator. 4 times 4 is 16, 3 times 4 is 12. 15 minus 12 is 3/16. Uh-oh, I have a problem. 3/16 does not equal 1/8. This is not an arithmetic sequence. The D is not equal, so it's not constant. It's not an arithmetic sequence. So let's review what you have to do to determine arithmetic sequence. You have to figure out your D for each one by figuring out what it is to get from one term to the next term, and then that term to the next term, and then see if the D's are always equal. So here's some examples for you. I would like you to do these examples without me. Negative 26, negative 22, negative 18, negative 14. Is that an arithmetic sequence? How about this one? 1, 4, 9, 25. Is that an arithmetic sequence? So do that workout. Pause the video. All right, so now we're back on negative 26 to negative 22. that would be adding 4 to get that. Negative 22 to negative 18, we add 4. Negative 18 to negative 14, we add 4. This is an arithmetic sequence. D equals positive 4. 1 to 4, we add 3. 4 to 9, we add 5. Not an arithmetic sequence. Okay, we're going to go over here. Now we're going to try to figure out how to find the next term. So how do we find the next term? Here's your problem. Find the next term of the arithmetic sequence. Okay, so we go from 15. How do we get from 15 to 9? Well, that's a minus 6. How do we get from 9 to 3? Well, that's a minus 6. How do we get from 3 to negative 3? Well, that's a minus 6. This is arithmetic sequence. So the next term is going to be negative 3 minus 6. So when you have two negatives, negative 3 on a number line, minus 6, you're going to add the two numbers and keep the sign. The next term would be negative 9. That would be your answer for that. Find the common difference. We did. We found it. It's negative 6. And then add the common difference to the last term. We did that. It's negative 9. Okay, so here's another example for you. Find the next 4 terms in the arithmetic sequence. Okay, so we go from 9.5, 11.0, 12.5, 14.0. So I want you to turn it off and try to figure out what the next 4 terms are. Okay, we're back on. What you have to do is figure out, how do I get from 9.5 to 11.0? Well, if I subtract the 2, 11.0 minus 9.5, remembering all the time when I'm subtracting with decimals that I have to line the decimals up, I'm looking for my difference, and my difference is plus 1.5. How about to get from 11 to 12.5? So from 12.5 to 11, I find the same difference, 1.5. And you're going to find that each one is going to be adding 1.5. So how do I get the next 4 terms? 14 plus 1.5 is 15.5. That's your next term. That's the next one. The next one would be that. After that would be that plus 1.5, which is 17. And then if I add it again, I would get 18.5. And then if I add it again, I would get 20. So those are your answers for the next 4 terms. So what you're going to learn is that each term in an arithmetic sequence can be expressed using the first term and the common difference. There's a little formula that I'm going to teach you. We call the first term in an arithmetic sequence A with a little sub 1. Okay, so it's A1. The second term is going to be A2. The third term is going to be A3. The 50th term is going to be A sub 50. Sometimes in math we have to use an unknown. We don't know what the term is going to be, but we want to create a formula when we don't know what the term is going to be. So we use the letter N a lot in math. So we're going to call it the nth term. So that's going to be A to A sub n. Okay, so AN. We know that the common difference is D. So here is the formula to find any term in an arithmetic sequence. A sub n equals the first term. You're always going to take the first term, and then you're going to add D times that n minus 1. So for example, okay, if I had my first term was 10, I'm going to just use this formula, and I'm going to show you how this works. Okay, so let's say my first term is 10. My second term is 12, my third term is 14, and then 16. Okay, and then dot, dot, dot. So my first term is a to the 1. So this one is a to the 1. So if I want to figure out my third term, I'm going to go a to the n, which the third term is going to be a to the 3, equals the first term, which is 10, because I'm going by this formula right here, okay? The first term, a to the 1, plus d. My d here is positive 2. If you notice, I added 2 each time. So it's going to be 2 times my n minus 1. N minus 1 is 3 minus 1. 3 minus 1 is 2. So my third term in this sequence should be 10 plus, using PEMDAS, 4, which is 14. And you notice that 14 is my third term. Okay, so I'm going to show you how do you figure out, let's just try to figure out the 12th term, okay? I could sit here and go 10 plus 2 plus 2 plus 2. So I could go 16 plus 2 is 18, 18 plus 2 is 20, 20 plus 2 is, and I could keep going out until 12. Or I could just use the formula. The formula is a to the n equals a to the 1 plus d times n minus 1, okay? So I said the 12th term, so let's figure out the 12th term. A to the 12 equals, a to the 1 is always the first term. 10 plus d is always whatever the difference is, plus 2 times 12 minus 1. 12 minus 1 is 11, okay? So without doing this all out, I'm going to figure out that my 12th term in this sequence is 32. I don't have to do all that work, okay? So that's how you use that formula. So here's another type of problem. We're going to write an equation for the nth term of the arithmetic sequence. So step 1 is you're going to find d. So let's see what d is. What do I do to negative 12 to get negative 8? I add 4, I add 4, I add 4. d is 4 in this case. Write the equation using a to the n equals a to the 1 plus d times n to the 1. Okay, so we're looking for the nth sequence. I mean the nth term. We don't know what that term is, but we want just a general formula for this particular problem. So my a to the n is going to equal a to the 1. Which one's a to the 1? You go to the first term, 12, negative 12. So it's going to be negative 12 plus d, 4, times n minus 1. Now in this case, I'm just going to have a general formula. I don't know what n is yet. But I want some type of formula that I can plug anything for n in and still figure it out. So all you have to do is say a to the n equals negative 12 plus, what property we notice here? This is distributive. You need to distribute your 4. 4n minus 4. I distributed 4 times n is 4n. 4 times negative 1 is negative 4. And now I have to combine like terms. I have a negative 12 and a negative 4. These are two negatives. When I add two negatives together, I keep the sign and I add the numbers. So my final formula for this problem is a to the n equals negative 16, because I added those two, plus 4n. Okay, well, what am I going to do with that? Find the nth term in the sequence. Okay, I have my formula. This is my sequence formula. So a to the 9 equals negative 16 plus 4 times 9. Okay, so negative 16 plus 4 times 9 is negative 16 plus 36. 36 minus 16 is 20. So my 9th term in this sequence is going to be 20. Let's see if that's true. Okay, my d was 4. So I'm going to say add 4 to that, I get 4, add 4 to that, I get 8, add 4 to that, I get 12, add 4 to that, I get 16, and add 4 to that, I get 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is my 9th term, so this is correct. Now, it says graph the first 5 terms. You're going to go, what do you mean graph the first 5 terms? Well, these terms are always going to be your y when you're graphing, okay? So these are always going to be your y. So we have to figure out what are your x's. Well, your x's are always going to be this. This is your first term, this is your second term, this is your third term, this is your fourth term, this is your 5th term, and so on. So the way you graph it is you're going to graph 1, negative 12. So here's my graph, just like you know how to graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12. The next term, coordinates in this graph is 2, negative 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. Then I have 3, negative 4. 3, 1, 2, 3, 4. Then I have 4, 0, 4, 0. And then I have 5, 4. 5, 1, 2, 3, 4. If you're doing this on graph paper, you know me, I can never get things straight. This will come out as a straight line. Mine did not. Okay, so make sure you have all your notes done and we'll see you in class.